The joys of live broadcasting.
Yeah, I don't know. Don't know what happened. Okay, here we are.
Can we skip the intro?
I'll just go ahead and start the program
Yeah.
and delete
Give
the.
everybody a chance to get back in.
Yeah. There they go. They're back on now. There we are. So, Kent, it's your 30th episode. And because it's your 30th episode, what are you giving away? You got to give away something.
Well, since it's the 30th episode, let's give away an eyepiece. A
Cool.
30 degree eyepiece. How about that?
How about a 30 millimeter eyepiece?
Well, what I say, a 30 degree? Yeah, 30 millimeter eyepiece.
You could give away a Huygens 30-degree eyepiece.
I don't think we have some.
That crowd will like it much.
I don't think we have any Huygens or Kellners, either one.
No, the
At
Kellner,
that 30s.
Kellners are like 40 or 35 or 40, and the but Huygens about 30. Yeah.
Mike Wiesner asks, "Is this live or Memorex?"
If you can remember about Memorex, then that says something right
Yeah,
there.
there's a cultural reference entire generation won't get.
Time generation gap right there. That's right.
I'm getting this weird stereo effect in my headphones that I haven't had before.
Oh,
Yeah, that was really weird. That it just,
weird. So you heard a pop and then it was gone, huh?
yeah, it was almost like, the sounds you get when you unplug headphones or a speaker or an amp, plug in RCA plug into an amp. That was sort of like what it was.
It was weird because I didn't touch any of the connections or anything like that, and then I just saw the microphone start to work again. So there you go.
Yep, that was really weird.
That's weird.
The joys of live broadcasting, as I said.
The joy, actually. Booming, Scott low by comparison. How about now? How about now?
Scott started doing this thing about not swinging his boom mic over.
That's true. I don't know why. I have no idea.
Hey, Scott, did you see Pekka is not going fishing tonight?
Oh,
I
cloudy?
guess it must be cloudy.
Must be cloudy. Yeah.
And he noted that the electric eel is still there.
The electric eel?
Eel, yeah. He's fishing for the electric eel, the light.
Oh, well, we're glad to have you all back here on Friday, and so that we can cover some of our favorite subjects here. How to explore the universe.
up for April. Morning planets, a sunset arch, and finding Leo the lion. The morning sky on April 6th finds Jupiter and Saturn forming a lovely trio with the crescent moon. Look for them low in the southeast in the hour before sunrise. April 22nd is Earth Day, an annual opportunity to collectively appreciate the wonder and beauty of our home planet. So it seems appropriate to feature an Earth-related sight you can see any time of the year when you have clear skies. It's a twilight phenomenon that you might have noticed just after sunset. If you can pull your gaze away from the sunset in the west and spin yourself around to face east, you'll often notice a band of pink or orange-colored sky with a darker bluish band underneath. These bands move upward over the minutes following sunset to form an arch across the sky that slowly fades as night sets in. The dark band is Earth's shadow rising. Above it, the rosy-hued band is known as the Belt of Venus. We observe this sight for a short time after sunset when the sun is just below the horizon, but some of its light rays are still making their way through the atmosphere before nightfall. Shorter or longer wavelengths of sunlight are able to travel the longest distance through the atmosphere, and at the point opposite to the sunset, this reddish light is scattered off the atmosphere and back toward your eyes. The Belt of Venus is named not for the planet, but for the mythical goddess. Together with Earth's shadow, these sights form the anti-twilight arch. This arch rises like a curtain on the night, slowly fading as Earth's shadow eventually fills the sky, allowing us to gaze outward into the stars. You can see this sight in morning twilight as well by looking in the direction opposite the rising sun, that is, toward the west. As the sky begins to lighten, Earth's shadow becomes noticeable with the Belt of Venus above it, and these bands slowly sink to the horizon as day breaks. April is a great time to look for Leo. That is the constellation Leo. Leo is the Latin word for lion, and this well-known grouping of stars is named for a superpowered lion vanquished by the mythical hero Hercules. It's a pretty easy constellation to locate because it sort of looks like a lion reclining in the sky and has this recognizable curving shape called the sickle that represents the lion's head. In April, you can find Leo high overhead in the south in the first few hours after sunset. In addition to the sickle shape of the lion's head, look for the lion's heart, the brilliant bluish-white star Regulus, which is one of the brightest stars in the sky. Astronomers think most stars have a family of planets orbiting them, and these two bright stars in Leo, named Algiba, which is actually a double star, and Rassilus, each have a confirmed planet larger than Jupiter orbiting around them. So step out after dark in April to look for Leo with its sickle-shaped lion's mane and blazing bluish heart. Here are the phases of the moon for April. You can catch up on all of NASA's missions to explore the solar system and beyond at nasa.gov. I'm Preston Dykes from NASA's Jet Propulsion Laboratory, and that's what's up for this month.
Well, hello, everybody. This is Scott Roberts and Kent Marts here, and it is Kent's 30th show of FirstLight Chronicles. So, sorry for the hiccup that we had. I've had a couple of those recently, but anyways, I think we're all... we're back on and everything's good at this point. Is my voice sounding kind of echoey, or does it sound okay? Or and you're muted, Kent.
It sounds it's echoey sort of, but it may be a stereo effect. Like your microphone is now working in stereo where it had in the past.
I see. That could be.
Because
Well, it is new software that I'm using right now, so not for the microphone, but for the actual broadcasting part of it. So maybe it's better. Maybe. But yeah. So Book said, sounds good to me. Norm says good. Okay, but work is good. Okay. Anyways, so it's your 30th anniversary show, or 30th program, and you're going to give away a 30 millimeter eyepiece. And so
Yep.
how are you going to do that? You got to,
So it's a 52-degree eyepiece. We don't have very many left in stock. So
Okay.
I'm gonna ask a question,
okay.
and
So
we have to,
we'll have them answer it, and then we'll pick the winner before the end of the show.
correct. We'll have a answer in the restream,
Okay.
and and once we get it, then whoever we announce the winner can email me their address, and we'll ship it off next week. So this has been something that if
Now,
you've been,
you should probably still have them email it in.
yeah, I mean,
What
yeah,
do we do? Explore Alliance.
email the answers in.
Yeah.
Okay, just email the answers in then. Yeah,
Because
Explore Alliance.
some of the streams happen before other streams. So,
True. Yeah, this isn't about being first. It's just about answering the question, and then we'll draw a name out. I'll just use a random number generator. We get 15 answers. I'll real quick just log in on the internet and use a random number generator, generate a number between 1 and 15, and that'll be the winner. So it's a 52 degree, 30 millimeter eyepiece. And the question is this: if you've been watching the FirstLight Chronicles with the Universe Sampler session after session, you've now seen this answer at least probably 7 times, and I have said the answer probably more than that.
And I said it too because I gave one of the presentations.
That's right. That's right. So
Okay.
the question is, who wrote the Universe Sampler? You've seen a slide every time. It's the second slide every time. Who wrote the Universe Sampler? I don't know if you can Google or not. Who wrote it? Yep.
Okay.
And I'll even give you a hint.
Okay.
It's a woman.
Okay.
So I don't know if you can Google this or not. This may be. I didn't try Googling. Let me just try that real quick.
Kent's going to do it for you.
Yes, there is. We picked a question they can Google, but that's okay. We want to give something away, so
That's right. We're going to. That's
we're
right.
gonna give something away. So anyway, start sending in. We'll go on and right before the end of the broadcast, we'll announce the winner. So,
All right. So
I'll announce.
that.
Yeah,
I'll recognize some of the people that are on
sure.
today. We have Pekka from Stockholm, Sweden. Mike Wiesner. I don't know if it's still windy and cloudy in Arizona, but hopefully it's clear. Martin Eastburn. He said it sounded like a cable dragged out of the mic or computer. It had a burp sound.
Yeah, I agree with that. It was like, pop or I mean, something like it was real instant and it was over
Maybe
with.
it was me. Maybe I did it. Maybe I had indigestion. Anyhow, Mick Whitaker's on with us. Of course, James the astrophotographer. Brian Fanning. Cameron Gillis. Howdy all from Seattle. Deja vu. We've got, let's see. Who else? Lots of chatter between you. I think Beatrice is on. Beatrice says hello. Andrew Corkill. And he says, hi again. I'm just starting to hear Scott again. That's good. Mike Wiesner says it's clear and calm here in southern Arizona for a change. He'll be in the observatory tonight. That's good. Chat is back and sound on entry for Martin Eastburn. That's good. James says 5 by 5. And Norm Hughes is on with us, and of course Book Davies. Nick says he's back at work, which means I'm down to 2 nights a week. Well,
That's both good and bad.
that's good and bad. That means money's coming in, and you can always watch these shows and rerun.
Has Scooter been on? I haven't seen Scooter's name recently.
Oh yeah, I don't know.
We may have to check on him, just because it was such a regular for such a long time.
He was, yeah.
Yeah, I may check on him. Yep.
Beatrice Hines says, hello, stargazers. And very nice. Jeff Gordotowski. He says, we met many times at Riverside Telescope Makers Conference and the Global Star Party. So, Jeff, thanks for signing on. That's great. And I think that's everybody. Dusty Haskins is on. I finally made it to one. It's been a while for me. For me too. Work has been crazy. And Beatrice says, here in Belgium, it's again windy, cloudy, and cold. It was clear, cloudy, or clear, windy, and cold a little bit last night. So, and Jeff says the Golden State Star Party. That's right. So, anyhow, which chapter are we starting on?
We are starting on chapter 9, the art of seeing. So let me get set up here.
Relates to looking, right?
That's correct. So are we up?
Yep.
Okay, no. So Astronomical League Universe Sampler class, lesson 9, the art of seeing. So normally the next slide would be the answer to the puzzle. But guess what? I deleted it.
You deleted it.
I'm such a meanie. Okay. So the Universe Sampler Observing Program is the whole point of this class is, the book is $13. Please buy the book from the Astronomical League. One, the money goes, the little bit of money they probably make off of it supports a good cause. The Astronomical League, an advocacy group for us. And there's the link for the Observing Club. Start, working through the Observing Club and get yourself an Observing Award. It's easy. It just takes a little bit of effort in making records. If you're not a member of an astronomical society, an astronomy club or whatever, that is a member of the Astronomical League, you can join the Astronomical League as a member at large. It's a bit more expensive, but gives you a link to a big community. So, reviewing lesson 8, recording your observations. To earn the Universe Sampler Observing Club, you have to record your observations. That are things that must be included in your observing log. That's outlined in the club rules. Recording your observations offers satisfaction for years later when you start reviewing what's done. And, I've said this before, I wish I would have done what David Levy did and written down every observing session I had. It would be cool to go back and see from age 6 or 7 when I was old enough to write to see what we did with my dad and just the efforts we made and all those other times. So lesson 9, the art of seeing. And Scott and I have discussed maybe this needs to be changed to the art of looking or something, because seeing, we just talked about seeing in the previous chapter as in how stable the atmosphere is in relationship to seeing and transparency, what makes the stars twinkle. So maybe I began advocating with the Astronomical League to change that to the art of looking. This is all about your eyes, okay? The amount of detail you can detect, and seeing detail is an art, just like anything else. Being able to see things is art. There's a big museum here, the Crystal Bridges Museum of American Art, and in it are many famous paintings. Rosie the Riveter is there. What you got, Scott? You're holding something up. Oh,
yeah, but we can only see you and the.
Oh, okay. Yeah. So we'll get there in a minute. Okay. So Rosie the Riveter's there. We've all seen it, at least probably in the United States anyway. Rosie the Riveter is a huge thing. It's giant. It's huge. It's big, like taller than I am, and 5 or 6 feet across, maybe 8 feet tall. And you start looking at it, and the colors are dark and not vibrant. And some people walk up and go, "Okay, it's Rosie the Riveter," and walk off. Well, I stood there and looked at it, and studied it and started thinking, okay, why are the colors dark? Well, it was a dark time when Rosie the Riveter was drawn.
That's
It
true.
was in the early the stages of World War II, and the 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 colors reflect that. And I noticed that Rosie was standing on something I'd never noticed before in all the pictures, because probably you couldn't read what it says, but she's standing with, I believe it's her left foot on top of a copy of Mein Kampf. And I was like, wow. And so
Hitler's book, right?
Hitler's book. So the point of it is, the more I stood there and studied it, the more I started seeing context and seeing things. Much the same thing. Like, I think if I go to see the Mona Lisa, which is a very small painting, I'm probably going to stand there and look at it for an extended period of time, as opposed to go, okay, I've seen it and walk off. And that's what we're talking about, learning to see. Sky conditions. If the sky conditions are terrible, say in windy, cloudy Arizona with Mike Wiesner, might not be really a good situation to do any observing. What's your telescope like? Is it badly collimated? And when it starts talking about dirty optics, it doesn't mean a little bit of dust. A little bit of dust has no effect at all on your telescope. Newtonian telescopes prove it, because all Newtonian telescopes have a big old, secondary right in the middle of it that frankly is a big piece of dust, right? It doesn't affect seeing at all. How dark adapted are you? Dark adapted. It takes really 45 minutes for your eyes to get good and adapted. Now, something I had forgotten, there's something called visual purple. And the photosensitive red and purple pigments in the rods of your eyes take time to get generated up to where they start really observing in that dim light. And, any white light at all, or even as the next bright red light, if your red light is too bright, it will degrade your night vision. And this goes to the point that some people wear red goggles or sunglasses at night to protect their night vision when they're not actually looking through the telescope, which is an interesting idea. I've never done it before because I've generally been in dark skies like that at star parties where it's not an issue. Averted vision. This is something that some people have a hard time learning to do. It's not about looking right at something. You can't see it because you're looking into the part of your eye that's not light sensitive. The rods are on the outside edges of your eyes, and you've got to learn to look off to the side of something to be able to detect it with your averted vision. And the blinking planetary nebula NGC 6826 in Cygnus, if you look directly at it, you can't see the central star. But if you move away, you can see it. You can see it blink, but without averted vision, you can't see it blink. So learning to use that averted vision to see things is important. You have to train your eye to see. Like I was talking about, a cursory glance at an object is not observing. It's looking at it. Take time to look at it, to study it. Spend minutes, spend half an hour. The longer I look at Saturn, even if it's a small, really crisp image, the more I start seeing. It's just like standing in front of Rosie the Riveter. The more you look, the more context you start to get. You're looking at a spiral galaxy. Do you see arms? Immediately you won't. But as you start looking at it, you're going to start seeing more and more detail. You're going to start teasing out. Like it says here, if you're looking at Jupiter and you only see 3 moons, can you see a shadow on the surface? Is there a moon in front? Can you find that moon? There's all sorts of things you can do. Bell Nebula, it's real wispy. How many wisps can you see? The trapezium in the heart of M42. Can you really only see 4 stars, or are there more? The more you try and look, the more you're going to see. It really takes time to start to learn to have your eye actually see. And this talks about when you start drawing an object, you're forced to really look at it, to study it, to figure out what you're wanting to draw. And the more you draw, the more you can see.
Yeah.
And again, the dimmer the red light you can use, the better off you are. So that's that. I didn't have time to get any graphics and pictures together. As I round this out for the Astronomical League, I will. So lesson 9, we're going to review. The scene here does not refer to atmospheric effects of how an object looks. You have to learn to see things to see them in detail. Learn the techniques to see more than you thought you'd ever be able to see. And there are many, many things that can lead to seeing things well or seeing things poorly. Work on those. And next lesson is the moon. It's the biggest, brightest, easiest to find object in the sky. Goes through a 28-day cycle, changes by the minute. There are literally hundreds of things to see on the moon. We're going to talk about the moon next week. And I will have pictures and graphics. So, asking the question again, who's the author of the Universe Sampler? So we got a few more minutes before we're going to shut it down. But who is the author of the Universe Sampler?
Okay. All right. And while you're doing that, I will share another slide from the Power of Stargazing. This slide has to do with gratitude. And, and gratitude can do a lot for you. Let's see if I can pull that up here. Here we go. This is my slide on gratitude. And the point is about gratitude is a good subject to think about and to contemplate on is our own star, the sun. And, without, you can think of a zillion things that the sun is doing for us. It's a very, very cool astronomical object to observe, especially when you see dramatic flares and all the rest of it. But think of it in this way. I mean, the sun has been there for us for billions of years. And it is, it's what gives us warmth. We are the exact right distance away from the sun, so that we don't freeze to death or burn up. The sun is stable. Everything about it is just amazing, and I think that one of the things that really gives you a very sacred feeling, kind of similar to, actually more amazing than seeing the Milky Way, which also gives you a very sacred feeling, is to see a total eclipse of the sun. And when you see that happen, I mean, it's just, if you've never seen one before, you can hardly believe it when you do. And, spending more than a few minutes, just watch the sunset sometime, or, as you're observing through it with your safe filtered telescope, think of in a way of generating gratitude. And you'll find that start to reflect in many other things in your life. But the sun is also this very natural thing to look at. It's gratitude does many, many beneficial things for you. So, and also is one of the aspects of kind of reducing the impact of problems and worries that you might have. So it's just one of the things I like to talk about on our programs is that astronomy and stargazing is good for you.
It's sort of like approaching life. People, it's an attitude of gratitude is a lifestyle. Every day I wake up, I'm thankful to be awake, because the alternative is there's roots growing down towards my face, and meaning I'm probably in a coffin, dead in the ground, and it's just, you start off that way. You just live the day happy to be alive. And, right. When it's 20 below like it was, I was thankful for that, because you know what? I felt alive in a different way I'd never felt alive before. Now, and I'm just thankful for that stuff. I just try and approach it that way. Okay. So last time, we have 1 minute after I say the question. Okay. We got 13 answers right now. Who wrote the Universe Sampler? Who's the author of the Universe Sampler? So we can chat.
Seconds, right?
Yeah, you got 1 minute to answer from now. So give or take a few seconds. So get them in, and we will then go to a numbers generator real quick. Normally I'd have to write them all down and cut them up, but now I can just put in random number generator.
Mix them all up in a fishbowl.
That's basically what I'm doing.
Yeah.
So I'm going to count them again to make sure I'm not messed up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All entries all have the right answer.
Okay.
So let's give it another 30 seconds. Just in case, because, it takes 15, 20 seconds for everything to get out. And, Facebook runs about 15 seconds behind. So I'm assuming everything else is probably.
You'll probably get another 100 answers.
Yeah, in the next 10 seconds. So, all right, we'll add a little bit more. So it's 4:47. Hope everybody's having a great day. Light pollution. Fight light pollution. PEC is fighting light pollution.
That shows you fighting light pollution.
Yeah. I had a friend on Facebook says, this stupid bird chirps all night long. It sounds like a seagull outside my house. And I went, and I know where she lives. And I went, well, it's probably too much light, makes the bird think it's daylight and sits there squawking all night long. And she said, why would that make the bird squawk? And I said, because it thinks it's daytime and it's dawn and waking up. And so it squawks all night. Birds asleep don't squawk. You haven't had to sleep. Okay. So 13 is the answer. Here we go. My random number generator disappeared. All right. So from 1 to 13, generate the number. The number is 10, which means that, sorry, James, you missed it. It just popped in. Number 10. So that is, let's go to count these down, make sure I don't make a mistake. Okay, I'm going to read the names off of the people who entered. George Garcia, Andrew Corkle, that's 2. Michael Wiesner's 3. Krista White's 4. Okay. Dusky Haskins 5. Jeff Weiss is 6. Cameron Gillis is 7. Christine Fanning is 8. Pekka is 9.
Oh. Who's 10?
Book Davies.
What's that?
Book is.
Book Davies.
Book Davies. And there we go. So, okay. Book, I've got your address, Book, and I'll get your eyepiece out next week.
What? That's right. You won, Book, big time. It's awesome. So yeah, Book, you need to go out right now and buy the Super Lotto numbers because you're pretty lucky today. So
now on my 100th episode, Scott will probably give away a 100-degree eyepiece.
Oh, absolutely will. Absolutely will. That's right. Yeah. So you're going to want to keep watching. Okay. So, anyways, it's been a great day, and we hope you guys have a nice weekend. A lot of us are out there getting. I now have my reservation for my second vaccine injection, so I'm looking forward to that. And for all of you out there, stay healthy, stay well, and enjoy your night skies, and take care. And we will see you back on Monday. So I guess you're back on again, Kent.
Am I doing Monday again?
Oh no, I'm sorry.
As I say,
no. That's going to be Daniel Barth. That's right.
Yeah, as I say, I can probably pinch hit for Daniel real quick. I'll have to get his book and look up it. But for those of you who do outreach, Daniel has given me already tons of ideas. Download his book. Brilliant, fun stuff.
Oh yeah.
Yeah.
All right. Okay, so next up there's about it's almost a 30-minute presentation by NASA that I think you guys might enjoy. So until then, keep looking up, and we will see you next week. Bye.
Bye, everybody.
Bye-bye.
Ignition sequence start.
Good morning, and welcome to this peek inside the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. These men and women are monitoring the systems on the orbiting station and assisting the Expedition 64 crew members as they wrap up another full week of supporting scientific research in space. Commander Sergei Ryzhikov and his American, Russian, and Japanese crewmates are looking forward to an off-duty weekend before the crew of Resilience suits up for a first-of-its-kind relocation of this commercial crew vehicle from one docking port to another.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week we celebrate science aboard the International Space Station. NASA's Stratospheric Aerosol and Gas Experiment 3, or SAGE-3, celebrated its 4th anniversary of its FirstLight measurements aboard the International Space Station. This experiment is the most recent in a series of SAGE instruments that have measured stratospheric gases and aerosols from space. Launched this station in February of 2017, SAGE-3 is helping scientists monitor the recovery of ozone resulting from the reduction in emissions of ozone-depleting substances. SAGE-3 has also measured the intrusion of aerosols in the stratosphere from intense wildfires in Australia and California and from volcanic eruptions. The SAGE family of instruments started in 1979 and is one of NASA's longest-running Earth-observing programs. Data from SAGE-2 helped confirm human-driven changes to the ozone layer, which contributed to the 1987 Montreal Protocol that banned some of the most destructive industrially produced ozone-depleting chemicals. NASA's SpaceX Crew 1 astronauts aboard the space station will mark another first for commercial spaceflight on April the 5th, when the 4 astronauts will relocate the Crew Dragon spacecraft. NASA astronauts Michael Hopkins, Victor Glover, and Shannon Walker, along with JAXA astronaut Soichi Noguchi, will undock Crew Dragon Resilience from the forward port of the station's Harmony module and dock to the space-facing port. This will be the first port relocation of a Crew Dragon spacecraft. The relocation will free Harmony's forward port for the docking of the Crew Dragon Endeavour, set to carry 4 crew members to the station on NASA's SpaceX Crew 2 mission. The Crew 1 astronauts are scheduled to depart to the station and return to Earth on April the 28th, leaving the space-facing port of Harmony vacant. A Dragon cargo spacecraft carrying several tons of supplies and the first set of the new solar arrays for the space station is scheduled to launch this summer and requires the space-facing port position to enable robotic extraction of the arrays from Dragon's trunk using Canadarm2. Live coverage will begin at 6 a.m. Eastern on NASA television, the NASA app, and the agency's website.
Station, this is Dr. Francis Collins with National Institutes of Health. How do you hear me?
During a recent in-flight conversation, NASA astronaut and microbiologist Dr. Kate Rubins had an opportunity to talk to one of her science heroes, Dr. Francis Collins, director of the National Institutes of Health.
You're doing great work up there. We're all fascinated by the way in which science is being conducted right there on the International Space Station. And I hope people who are watching this, dreaming a little bit themselves, could imagine doing something like this. It's a path forward. This is the best time, tell me if you agree, to be a scientist in the history of the planet, because so many things are possible.
Not only is this an exciting general time in the space station history, I'm having fun actually today, right now. There's a lot going on up here, and I really do think that science is an incredible career, whether you're doing it in space or on the ground. If people are interested in this, the pleasure and the gratification of being a scientist every day, it's truly amazing to get up and discover new things.
That's Space to Ground this week. Thanks for watching. We'll see you next week.
In their time living and working on the International Space Station, the astronauts who arrived on the Crew 1 spacecraft have gotten into the routines of the mission. They've done spacewalks. They're about to take a trip around the neighborhood. Well, let's go behind the official biographies and let these astronauts reveal a few inner truths about their favorite foods, the hardest part of training, and what is still on their space career bucket list.
Steak.
Anything with lots of zip.
Sushi. Princess Bride. Star Wars. The Replacements.
I like quirky movies. I'll go with Oh Brother, Where Art Thou?
The Moonwalk.
I like salsa dancing.
Spring. Always spring.
Spring.
I like places where you don't really have seasons, but I guess living in California, like going to college in San Luis Obispo, it felt like spring all the time, so maybe that's what I guess I like spring.
A good wedge of Parmesan cheese.
Yogurt. Greek yogurt.
Let's see. Ranch dressing. That's a kid thing. Tea. Tea, of course.
Tea.
Coffee.
Wastefulness.
Pet peeves.
People who don't use turn signal. Come on, it's so difficult. Now be patient.
Don't be afraid. Be bold.
Smile more.
Spend the day on more.
So I'd probably run around and take lots of pictures.
Sand dune driving. Hey, you're on Mars. That's good enough. Don't worry. Be happy.
I believe I can fly. I don't know, that just comes to mind.
Ooh, that's a tough one. Russian language.
Physically, it's spacewalk training, and mentally, it's Russian language.
Leonardo da Vinci. Frederick Douglass. And I don't know, actually. How about that?
Dark chocolate.
Sleeping during meeting.
I get to do so many amazing things in my life. When I have the time and can afford to do nothing, I really like to do nothing.
Oh, parent. By far. Being a parent.
Parent. Hands down.
Hopper.
IKE. It's an acronym, stands for I Know Everything. It's a reminder to never pass up a good opportunity to keep my mouth shut.
Walking on the moon.
To work on the surface of the moon, that's a dream, absolutely.
I want to spend a single day without any calendar events. An officer in the United States Air Force. Therapist. I'm good at listening to other persons talk. Believe me.
I'd still be flying, but the other thing I loved doing was working with students. Being in a classroom is one of the most meaningful things I've ever done, even to this day.
Karaoke. Anything with my family.
If I could fly more, I would fly more.
Commander of time machine. So the kids say it should be telekinesis, but I think to fly.
Teleportation.
To fly. I think we have a trend here.
I got a sweet tooth.
Probably Mexican food or Indian food. Or maybe Thai food. Good question.
I would say Moroccan and Indian.
Favorite decade? Wow. Favorite decade? Right now.
80s? Because the 80s.
1980s? Because I was young and stupid. In that order.
The astronauts of Resilience, like their crewmates who traveled on a Soyuz spacecraft, spend some of their time working on science experiments that take advantage of the absence of gravity, such as when astronaut Doug Hurley squeezed a bag of fruit punch. The fluid that squirted out of the bag wound down a clear tube and soaked into a block of white foam, all to provide researchers with better information about how to manage liquids in microgravity.
Mark, station on 3, out of here. This is Doug. Doug, I got you, 5 by 5.
We started maybe 15 years ago in this long line of experiments that have been going to space that are all small-scale fluids experiments that have really taught us a lot about managing fluids in space without any moving parts, without any electricity, just fluidics. Now we can apply research results that we've learned from doing experiments in space to actual space systems that actually require gravity to be gone for them to work. That's different. That's a new horizon, I would say.
Okay, Mark, ready on step 4. This is an engineering demonstration of a wastewater purification system. So inside that foam, there are all these weird channels and different wetting foams in there, such that capillary forces wick the liquids out, opening the channels up. So it's a capillary solution to an engineering problem of managing brine and contaminated water streams.
Yeah, it sounds really, really interesting and frankly really cool. I can't wait to see what it does.
What you're going to do is you're going to open that little valve out of the drink bag, and you're going to prime the tube. Then you're going to squeeze that bag, the drink bag, and then kind of in about 15 seconds fill the entire foam with the contents of the bag.
The interior piece of that foam is highly wetting, so it wants to suck up that water. But then there are pieces on the outside that are hydrophobic, so it doesn't want the water to penetrate through. So how can we, mix that up? What are the issues? What does that look like? Because ultimately this piece of technology, even though it's so simple as a piece of foam, it can potentially do so many things.
If you watch the videos, you see it, you're going to think it's dull and what are these goofs doing? You're going to say that. But basically what it is it's a dyed liquid. It's actually red fruit punch that we use, which is a simulant for urine.
Do you like the backlight view?
Yeah, we're geeking out over that. It gives us the complete view of this whole thing. It's nice.
That's pretty cool.
So the purpose of this experiment is to see how well does the foam hold the liquid in microgravity, and if we completely agitate it and really put this piece of equipment through the ringer, how well does it bounce back? Honestly, the most surprising thing that's come out of it is how simple we can make this technology. Maybe the foam project is going to enable a backup system for the toilets, or maybe it's going to be a new wastewater processing system altogether, and that's just the future. It's just, it feels like anything is really possible.
We are very hopeful that our work, which started out in fundamental research and is turned more and more applied, can actually get to the point where it's delivering on equipment. Equipment that functions without moving parts, or a minimum of moving parts, without power, without noise. We'd love it to have a system that just works passively by its shape. And whether it's on the moon or in orbit around the moon or in way to Mars, we'd love to contribute in that way and in the way that makes others able to do that too. So by publishing the design laws, by the design experience, by the experiment experience, we'd love to do that too.
I think it's just cool. It's so simple and it's so cool.
Its position 250 miles above the Earth makes the International Space Station a great place to gather information about this planet. This one, right here. There is an instrument on board that gathers information about how plants on Earth sweat, and that provides data to scientists who are monitoring the health of Earth's vegetation.
Sweating can be cool. Presented by Science at NASA. Did you ever notice how the air can seem cooler when you enter a forest? Humans aren't the only living things that sweat to cool off. When trees and plants sweat, they cool themselves and can cool the surrounding air. Through a process called transpiration, water and nutrients are taken up by plant roots from soil and delivered to the stem and leaves as part of photosynthesis. Some of the water drawn up through the roots exits the plants through pores or stomata in its leaves, hence the sweating. As this sweat evaporates, heat is removed from the air, providing a cooling effect. However, if there isn't enough water available or relative humidity gets too high, the stomata close. The plant heats up, ceases to grow, and can eventually die. Healthy plants provide a number of ecosystem services to humans, including food, recreation, and building materials. Plants also impact Earth's global water and carbon cycles, with plant transpiration accounting for around 10% of the moisture in our atmosphere. A new NASA mission called EcoStress, short for Ecosystem Spaceborne Thermal Radiometer Experiment on Space Station, was successfully launched to the International Space Station on June 29, 2018. EcoStress will literally study how plants sweat, providing the most detailed measurements of plant temperatures available from space and helping researchers monitor the health of Earth's vegetation. Your temperature is one of the first things a doctor wants to know when you go for a checkup, says Simon Hook, EcoStress principal investigator from NASA's Jet Propulsion Laboratory. It tells your doctor a lot about your condition. Temperature is an extremely useful indicator for plants too. Temperature data can indicate if a plant is stressed and needs more water before the plant collapses, providing an early warning of a possible drought, explains Hook. EcoStress will be able to measure plant temperatures and therefore plant health over areas as small as an individual field of crops. The International Space Station is well suited for the EcoStress mission. Hook says, most Earth-observing satellites are in a sun-synchronous orbit, so they pass over an area at the same time each day, providing us a daily snapshot of that area. Because of the space station's orbit, EcoStress sees the same spot on Earth every few days at different times of day, so it can track changes throughout a typical day. If, during a hot, dry afternoon, plants stop releasing water to conserve supplies, EcoStress will see a change in temperature compared with previous measurements of the same area. It will detect these kinds of responses in farmers' fields and other ecosystems. Data acquired from EcoStress may, in time, help farmers develop crop watering protocols, give researchers a clearer understanding of the effects of drought, and assist water resource managers in planning effective water use. Its data could also reveal the effects of droughts on natural vegetation. For example, to help identify vulnerable types of trees. Forest managers and ecologists will be able to use this information to make better informed decisions. But that's not all. EcoStress temperature data will be useful in a whole host of ways, says Hook. We'll be able to use the same techniques developed to extract plant temperature to look at other phenomena such as the temperature of volcanoes, urban heat waves, wildfires, coastal currents, lakes, and more. That's a whole story in itself. Want to learn more about this cool mission? No sweat. Just visit science.nasa.gov.
The exterior of the International Space Station is home to many ongoing experiments. The one Isidro mentioned a few minutes ago is a third-generation investigation into the state of the ozone layer of Earth's atmosphere. The Stratospheric Aerosol and Gas Experiment has now spent 4 years measuring the ozone, aerosols, and other components of the atmosphere for scientists who hope to see an improvement in the atmosphere's ability to protect the planet and everyone and everything on it from harmful ultraviolet radiation.
SAGE stands for Stratospheric Aerosol and Gas Experiment. It's the third generation, so we call it SAGE 3. What it does is it looks at ozone, water vapor aerosols in the atmosphere using a solar occultation technique. So it locked onto the sun or the moon, and it tracks that as it rises through the atmosphere or sets through the atmosphere of the planet, so that we can get vertical profiles of those gases. More specifically, it's ozone that we're really tracking. We hope to see recovering ozone throughout the entire stratosphere. So, and you know, ozone's very important. It protects us from the UV radiation. Without that protection, we would have lower crop yields. You know, our plants really don't like UV radiation, and we would have problems too. We would have more skin cancers and cataracts. So we really need that ozone layer in the stratosphere to protect us. I've been working on this for 20 years now, and it's going to be amazing to watch it up there, and you know, get up there and watch the data coming down.
Another major goal of the International Space Station is to help us learn what we need to know to support future space exploration, such as working out the systems of new spaceships to support the human needs of the astronauts on long journeys to deep space. That would include systems to provide clean water. In this installment of this demonstration video series, astronaut Drew Feustel discusses the water recovery system used to recycle crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions. And the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long duration missions such as here on the space station and will be for future trips to the Moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
As you'd imagine, performing science research on the ground can be very different than performing it in space. And many International Space Station crew members who spend time working up there come away feeling like they have undergone a profound change. Former astronaut Jack Fisher is one of them. Here he recalls his time in orbit and discusses how the spirit of exploration contributes to humanity's future.
The bug for space really bit me when I came down to visit my grandpa down here in Houston. So I saw the big old Saturn V rocket sitting on its belly out there and just thought, man, if humanity can do something this amazing, this awesome, I want to be a part of it. And I just fell more in love with the idea of space and being a part of something bigger than myself. The thought of actually getting to space, I couldn't wrap my head around that. You walk up to this rocket that's covered in frost from the cold fuel inside, and it's creaking and groaning and kind of alive, and you're like, well, that's pretty cool, but they're probably gonna cancel this. It's just not gonna happen. You know, I've done so many sims, and it just can't be real. There's no way I'm gonna go to space. But then when no kidding, it lights off and you feel the rumble, and then you start to move, and that kind of just constant smooth acceleration, pulling you back in the seat. Everything comes to life on the panels. You see all of the things that you've seen 100 times in sims. In one instant, all of that I felt was unimaginable became real. And it was a magical thing I'll just never forget. You know, we're scientists and engineers and pilots and doctors. We're not poets, but we sure try to be, because you want to share as best you can the experience that you've seen and felt. I think I told my wife once I got on board that I thought it was
It's a burrito of awesomeness smothered in awesome sauce, baby. It's so beautiful.
it was just the beauty of being there yourself with your own eyes and seeing it. One thing that I would love to do while on orbit was there was a window in one of the Russian modules that looked kind of out the back of the station. And I'd go sit there. I'd turn off everything and you could get it really dark in there, let my eyes adjust and just look out at the stars. And the stars, you know, the longer you sit, the more you see, and it becomes unbelievable. The number, the just billions of stars, the Magellanic Clouds, the galaxies that you can see with your naked eye. And they don't twinkle. They just stare at you. They dare you to come and to explore. It lights a fire inside your soul that is unlike anything I ever experienced before or since. And it's why you see astronauts, you know, they say 560, 580, I don't know how many people have gone to space. They're all the same. They all have that bug. And they all want to do everything in their power after experiencing that to make sure that humanity reaches its potential, that we get there, that we don't just see the stars, that we explore them, that we live there, that we grow into what we can be. And you're reminded of the incredible potential that we have as humans when we put everything else aside and just work together. And you feel a part of that, looking out the cupola and just being a part of thousands of people from across this globe that have put together this just palace in the sky for us to discover and learn and grow. It showed me the potential of what humanity can be when you work together as one team. It inspired me to do everything I can in my power for the rest of my life to enable humanity to evolve, to get there, to those stars that were staring straight in my face and daring us to come get them. That is something that you can never quench. It's been a couple years since I flew, and that fire still burns just as strong today as it will when I die.
If you want another look at any of the stories we featured today, you can always find them on YouTube and Facebook, where you'll also find a lot of other great features on a variety of NASA topics. Be sure to look around. If you are looking for good conversation about human spaceflight, then check out Houston, We Have a Podcast, a weekly show talking to folks involved in all areas of space exploration. Today is your chance to listen in on the insiders discussing International Space Station science, as our third Space Station anniversary panel discussion focuses on some of the outstanding research efforts and the things we've already learned from experiments on this platform. Go to nasa.gov/podcasts for this week's episode and all our previous episodes, and the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.
Hi, I'm Nagi Cox, a spacecraft operations engineer. I've been lucky enough to work for U.S. Space Command, in the commercial space industry as well, and now I'm at NASA's Jet Propulsion Laboratory working on the Mars 2020 Perseverance rover. Don't forget to visit MEEF, the virtual experience, April 10th, 2021. It's the world's largest space and astronomy expo. go to neathexpo.com. I hope you have a great time.
I'm Kent Marts. Explore Scientific recently added weather and clocks to our lineup. These clocks set their time within NHTSA's radio station to keep them accurate to the second. Our clocks come with a variety of functions. This one is a simple alarm clock, but other clocks come with features including projecting the time on the wall or ceiling, outdoor-indoor temperature, a host of other functions including weather forecasting. They come in a variety of sizes and colors, the colors being a black bezel or a white bezel. In the weather category, we currently offer a 5-in-1 and a 7-in-1 system that do time, temperature, wind speed, things like that, using the included outdoor sensor. This runs off of 3 AA batteries and lasts for a long time. The wireless connection allows you to send your weather data to Weather Cloud or Weather Underground. Additional sensors are available, including a thermal hydro sensor, a floating pool or spa sensor, and a soil sensor. For more information about these products or to purchase them, go to explorescientific.com. I'm Kent Marts with Explore Scientific.